Hello.
Hi, Arjun. It's great to meet you. I'm excited to dive into our conversation about Docker today. Let's start with the basics, and then we'll gradually build up to more complex topics. Could you start by explaining what Docker is and why it's useful in software development?
Yeah, sure. So Docker is this. It's a strategy or tool that we can use to package software. So one of the major things that Docker comes in and solves is basically the thing that most developers used to say back in the day. Like it works on my machine, but it doesn't work on it doesn't seem to work on someone else's. So Docker, the way it works is like it creates like a small sort of like a VM, but it's not exactly like a full fledged VM. It's like a very small reproducible environment in which code can run as it is expected to, the same way that it does on the dev's machine. And yeah, that's what Docker does. It gives a reproducible environment so that code can run reliably in exactly the same manner.
Absolutely. You've nailed it. Docker indeed provides that consistent environment, eliminating the classic "it works on my machine" issue. Now, let's take it a step further. Given your extensive background, especially in engineering roles, how have you seen Docker impact the way your teams handle deployment and scalability?
Okay, so Docker is sort of like this non-negotiable thing that we have in our team. So whether it is like a front-end app, a back-end, or any machine learning container, any ML model, whatever be the case, the biggest benefits that we've seen is, of course, one is reproducibility. Second is the fact that it's very easy to package it and ship it off, since there's like a consistent way to run it across the board, and it doesn't matter where you're running it. Like, of course, the chipset architecture, that might be something that might vary a little bit, but of course you can still build it for that architecture if needed. So one of the biggest ways, like I said, is of course reproducibility and reliability. And when it comes to scale, Docker containers combined with Kubernetes, which is just a Docker container orchestrator, it helps us build applications to scale, whether it's a single monolith or a microservice based architecture. So that's how it's helped us, throughout our software life cycle.
That's a comprehensive perspective, Arjun. It's clear you've seen the full spectrum of Docker's benefits, from development to deployment and scaling. Now, given your experience, particularly with machine learning models, how has Docker played a role in managing and deploying these models? Any specific challenges or successes you'd like to share?
Okay, great question. So when it comes to machine learning models, like there's two kinds of models that we tend to deal with. One is something that deals with GPU-based workloads, and the other one is something that that doesn't really need GPU, so it can run off of the CPU. So packages like scikit-learn and let's just stick to scikit-learn for now. So most of the algorithms or the ML models that are available in scikit-learn are something that can run off of the CPU. So over here, we don't really have big benefits, as I would say, like as compared to when it comes to GPU-based workloads. When it comes to GPU-based workloads, on the other hand, one of the biggest things that we've faced as issues, like when it comes to deployment, is getting the NVIDIA drivers right, the versioning right, the CUDA core version right. All of these, are nitty-gritty details that tend to mess up deployment and the velocity at which we can deploy. So one of the major wins that we've had just by switching to Docker-based deployments, especially for GPU-based workloads, is the consistency, and not just consistency, the fact that it'll work as expected, like time and time again. So if, let's say, on our local we are running on CUDA 10 or 11 or some version like that, we can guarantee that that version can be made available in the Docker environment, and your model is not going to perform anything weirdly or away from its norm. So I would say that's one of the biggest benefits that I've seen when it comes to machine learning workloads and the use of Docker in that.
That's an insightful breakdown, Arjun. Docker really shines in managing those environment-specific dependencies, especially with GPU-based workloads. It's impressive how you've leveraged Docker to streamline deployment and ensure consistent performance, particularly with the complexities of CUDA and NVIDIA drivers. Now, looking ahead, how do you see the role of Docker evolving in the context of emerging technologies or architectures?
So that's a really good question, actually. So it's not very recent, but it's been there for like a few months at this point. One of the major factors or the things that I like about Docker is you can publicly post images for, let's say, a database or a web service or whatever be the case. You can host these as artifacts that are easily runnable by anyone. Like you can just do a Docker pull and Docker run the image name, and it should, for the most part, start working. When it comes to emerging technologies, like I mean, in this case, let's just talk about AI and machine learning models, or let's say deep learning models, especially large language models like Quen and Llama 2, Llama 3, all of these models. So, what Docker has recently done is the same command that you can use for Docker run container, you can now do Docker run a model name. So, you don't have to go through the process of setting up these models to have it run up inside, let's say, an Ubuntu based container with the relevant NVIDIA drivers and so on. But in fact, these models are available from the registry itself as a direct one line model run command, basically. So I would say that that is one of the most exciting and biggest things that Docker has come up with recently, and I feel like that's got a lot of potential. It's going to democratize the whole process of like deploying any model at any environment, essentially, as long as you have the relevant hardware for that model. But of course, I would say that's something that I'm really looking forward to gaining more steam, and not just that. In fact, with these models being in the picture, it makes it easier for MCP servers as well to be sort of packaged and deployed as MCP server as well. So I mean, I haven't really spent enough time exploring MCP servers inside a container, but that's also one more emerging aspect that I would say could has like a lot of potential.
That's fascinating, Arjun. This evolution in Docker's capabilities, especially with the ease of deploying AI and deep learning models, certainly opens up new possibilities. The concept of running a model as easily as a container is indeed a game changer, reducing friction and accelerating deployment. And your point about MCP servers in containers adds another layer of potential. Given this rapid evolution, how do you envision the role of a staff engineer evolving alongside Docker and similar technologies?
So one of the things is I mean, if it's not already the case, I would say Docker would be like this non-negotiable skill that anyone and everyone should have, whether it's at the staff level or an engineer level. It doesn't really matter. It's sort of the equivalent to whether you know how to write code in any language. That's like a non-negotiable for an engineer. And similarly, Docker, I would say, is going to get at the same status level of as a non-negotiable skill. Especially if I'm hiring for my team, that's one of the things that I look as. It's it's not something that's very hard to pick up, and if you haven't spent enough time picking that up till date, considering the fact that it's been around for so long, then I would be a little concerned, by your exposure, the projects that you work on, and everything. So, long story short, to answer your question, I would say it's gonna be, if it's not already, it will be a non-negotiable skill. That's something that becomes a mandate over time.
Absolutely. It makes perfect sense. Docker is becoming as fundamental to engineering as coding itself. especially at the staff engineer level, where broad and deep technical expertise is expected. It's clear you've set a high bar for your team, and rightly so. As we wrap up, is there any advice you'd give to engineers looking to deepen their Docker skills or integrate it more effectively into their workflows?
Great question. So, in fact, to begin with, you need to know the fundamentals, like building and running a container on your local. Then, as long as you know how to push it to like a remote repository, both private and public, both of these are very important. Private is something that's going to be a non-negotiable when it comes to any organization. So, you should be comfortable running Docker login to authenticate and pull from these authenticated repositories. But these are like the bare essentials that anyone should know. Apart from that, there's always optimizations that you can do when it comes to caching. So the way Docker build works is like line by line, it goes through the whole Docker file and builds the cache, and that way the first build might take quite some time, but after that it doesn't take as long. So yeah, caching strategies is something that you could spend some time learning and picking up on. That way the whole process of the Docker build will reduce over time and your iteration is quicker. Apart from that, figuring out the right place at which you do all the package install versus code copy in the in the Docker file is also important. So these are some of the things I would say we should focus on.
Great advice, Arjun. Mastering the fundamentals and optimizing builds can really streamline your workflow.